Welcome back to our lecture series on elasticity. Here we're going to be doing our third lecture in which we're talking about having just finished talking through the ways to calculate elasticity, 3 different ways there. We're going to talk through some elasticity terms. I'm going to break this into 2 subparts. So we'll talk today just about the definition of elastic versus inelastic versus unit elastic. So we have these 2 terms, elastic versus inelastic, and they are going to be definitionally tied to this mathematical construction that defines elasticity. If you remember from our previous lectures, elasticity is about a response measured in terms of a percent changed divided by the action that led to that response, again expressed as a percent change. And for our applications, we're going to be talking about the response being a percent change in quantity and the stimulus or the action being a percent change in price. So we can map our elasticity numbers to a number line. Now I'm showing absolute values, but as I've mentioned before, they do have negative values for the price elasticity of demand. But because it's always negative, we typically just ignore that. So let's say, for example, we have a 1% price increase or change. Quantity can change as a result of that in a number of different ways. It's possible that there is no response, that there is no change. So the percent change in quantity is 0. This corresponds to an elasticity of 0. Now let's imagine there's a 1% change. 1% divided by 1% is 1. So we're kind of mapping those changes here to elasticities. If we have a 2% change, 2% divided by 1% is 2. So when we're thinking of what it means to be elastic versus inelastic, there is going to be a number that definitionally divides. And this is depending on the question of which is bigger, the response or the action. Again, we're talking about percent changes. And with our main application for the price elasticity of demand, we're talking about the percentage change in quantity divided by the percentage change in price. And so we're asking, is the percentage change in quantity bigger or is the percentage change in price bigger? If the percentage change in quantity is bigger, like with that example where we had a 2% change, we're going to get an elasticity that is greater than 1. If we have a percentage change where the price is larger than the percentage change in quantity, for instance, when we had a percentage change in quantity that was 0, elasticity is going to be less than 1. Elasticity also could be equal, and we saw that when we had a percentage change in quantity of 1%, exactly the same as our percentage change in price. These correspond to the terms. Elastic means it is moving a lot. And this is moving a lot when we have a large reaction to our stimulus, when we have a percentage change in quantity that is greater than price. So this is the elastic portion here of this number line representing values for elasticity. Inelastic is saying that we have a smaller response than action. And so elasticity is less than 1. When it's exactly equal, that is the dividing line between elastic and inelastic. We call that unit elastic. So just to emphasize, elastic demand greater than 1. It's when that percentage change in quantity is greater than the percentage change in price. Inelastic is when that percentage change in quantity is less than percentage change in price. In other words, with elastic, we have a very responsive demand, and inelastic, it's not very responsive. When they happen to be equal, elasticity is 1, that's unit elasticity. So here are just a quick view. We'll get into these a little bit more when we're talking about determinants of some empirical elasticities of demand. So you can see green peas responds very quickly and strongly to increases in price. Coffee is not very responsive. Movies are more responsive than going to the opera. And we'll talk in a later lecture about the determinants of this responsiveness, or the determinants of the level of elasticity of demand. Price elasticity, when we have a linear demand curve, which we will often be using in this class, follows a useful pattern in terms of being able to calculate it. So remember, we had derived this equation for elasticity that involves slope, the current price and the current quantity. As we move along the demand curve, so here's a demand curve that's linear with endpoints A and B. The slope is going to be constant, and the slope is negative A over B. But as we move along this demand curve, the price and quantity are changing. That's what's happening as we move along the demand curve. Moving left to right, we're decreasing price and increasing quantity. And so looking at this elasticity equation, places where the price is high and quantity is low are going to have a higher elasticity. So in this region, elasticity is going to be greater than 1. At the midpoint, you can actually mathematically show that it's going to be exactly 1, or unit elastic. In places where price is low and quantity is high, we'll see inelastic demand. And this is because our change as we move is the same for 1 unit change in price, but the baselines are being different. I want to highlight 2 special cases before we wrap up. The case of perfectly elastic demand. Here, any change in price leads to an infinite change in demand. So a small increase in price will lead to people buying no amount of that good. We'll talk a little bit more about where that can be the case later. And the other one is perfectly inelastic demand, where no matter how much you increase prices, the quantity is staying the same. The one thing I want to emphasize here is, as we can see with a linear demand curve, price elasticity is different at each point. So I really want to emphasize here that elasticity is not, even though we're showing it on these special cases, is not true for a curve, for a demand curve. It's a point or between 2 points concept. Right? Here we can see slope is the same. And in fact, for a given linear demand curve, it covers every possible elasticity. So we don't talk about curves as being inelastic or elastic, though at particular points, they can be relatively more or less elastic. Here's what I want to show in terms of that. With this particular setup, we have 2 demand curves that are crossing at this point of a price of 4 and quantity of 4. So they share a point. Price and quantity is the same for both curves. And so the only difference in elasticity is going to come from the slopes. So our steeper curve here, the one over the graph slope, is going to be steeper. So at this common point, the blue curve is going to be less elastic and less responsive to price changes. and the orange curve is going to be more elastic. So I covered here inelastic first, elastic curves. What we'll be talking about in our next lecture is a couple more terms talking about the price elasticity of supply, cross price elasticity, and income elasticity. Thank you very much for joining me, and I will catch you next